Hello friends, today we will see very interesting topic and that's a power supply. So basically everyone is aware of we are having 230 volt AC in our socket, like in a domestic. We have 230 volt at our home, and many of you know like it is a 50 hertz. Okay, so we have some discussion regarding this in our one of our lecture where we were talking about diodes, right? So 230 volt we are getting, that is the amplitude, and we it is repeats in a 50 times in a minute. Okay, so this will make it a 50 hertz. Now the point is many of we can say many of, yes, many of our components equipments are not using 230 volt directly. Okay, so if you have mobile phone, nowadays everyone have it. So if you guys have mobile phone, it have specific voltage ratings. So it is clearly mentioned on a charger. Okay, so we will have that. This is the adapter, and having we can easily say see here, like input is okay, so you are able to see this, right? So input is 100 to 240 volt of AC, 50-60 hertz is acceptable, and current is zero point 0.6 ampere. Okay, now the output, how much we are getting? We are getting 5 volt DC. You can see the symbol of DC, 2 ampere, and 9 volt 2 ampere. Okay, so this is the adapter where we are getting AC, input is AC and output is DC. So this is the power supply. So what is inside this? We will see that now. Okay, so power supply basically consists of few blocks. First we are giving AC. Okay, so we have transformer here which will step down the AC. Okay, now at the output also we have AC. That AC we are giving to the rectifier circuit. Rectifier circuit is nothing but the DC converter circuit, which we already studied. Just go and check the video of diodes. You will get to know what the full wave and half wave rectifier is. Now after the rectifier, you should be use a filter which filter out all the AC component present in the DC volt getting from the rectifier, and here is our filtered DC output. Okay, so this is the simple power supply and these are the only steps. Now here the point is we can use transformer or we cannot use transformer. Okay, so what's the difference in that? So while using the transformer, transformer is big in size, of course, which if it converts to 30 volt and stepping down it to 150 or less, then it is of quite big in size, which cannot fit inside this. Okay, and it's a cost, means its cost will make your circuit quite more costlier. Okay, so most of the circuit we are not using transformer. So what we are doing, we are making a power supply which is transformerless. So what now we will do, we will see the transformer power supply using transformer, and we will also see the power supply without using transformer. Okay, so in this video we will going to see transformer power supply. So let's start with that. So what is the basic circuit diagram for that? As we have number of things in here in already discussed. So first we will start with the transformer. So what's the symbol of transformer? This is how it looks like. Here we have AC. Okay, AC is not having plus and minus, sorry. So here is the transformer, and this supply is isolated, protects from the it is shock proof, we can say, because here direct connection is not there. We have this separation. This is the primary winding, this is the secondary winding, and here we get the step down AC. Now what we will do, we will put rectifier over here. So what's the rectifier? This is how rectifier we can draw, right? Remember, if you remember, then you can easily. Okay, now the rectifier circuit, and here we have negative, right? And here we have positive, which will go to here we use the capacitor. Yes, you can use electrolytic capacitor or ceramic capacitor. This is a ground, this is C1, and here we have IC. So which IC we are using? Now we are using 7805. What this IC is all about? This is nothing but the fixed DC output. So 05 indicates the 5 volt output. If the IC is 7809, so this 09 indicates 9 volt IC. So basically this is 78XX, and this X will indicate the output voltage. In same way, if you want a negative voltage, 79XX is there, XX will indicate the negative voltage. Okay, so this is the input and this is the output, and here it is ground. Okay, so we will make this ground. Here we again use one transformer, and here is our resistor, and for representation purpose we use one LED. Okay, and this is the R1, which is of 1K we will use. This is C2. Why these capacitors we use? Because here it will ground the AC component, same way it is working as a filter over here. Okay, let's start with the simulation. Just click on a Proteus, and by every time just need to go to new project. You just need to click here and give any name whichever you want. I'm giving transformer power supply over here, and then clicking next, 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 and just finish. Okay, after that I need to select the component which are there in a library. You need to click on a P. Here I'm clicking on transformer, and in a category you need to select inductor. You have to click on simple transformer, which you can see on the right side. By double clicking you can select the components. Now just go, and you can see over here you need to press you need to type here the diodes. And what are the diodes? 1N447. Okay, you have your schematic with you, I hope. So just need to click on the diode, and you just need to select the diodes. Then resistor, go for the resistor. This time we will see the resistor generic one, right? So we are just clicking on generic resistor symbol. After we can change the property of it. Now we need a capacitor also. So we will just go to check for the capacitor and LED here. Right now I'm checking for the LED, then we will go for the capacitor. So here we have animated LEDs. So just click on an animated one. If you select generic, then that time it will not show you visual effect. 7805 I have selected, and we will go with the capacitor. Generic one is mentioned over there, and we will change the properties later. Okay, hope we selected all the components. Now we will click on OK and process further. Here is our circuit. So we will start with the transformer. Of course, we are just placing it the place whichever we want. Okay, so just at the input side we need to give AC. At the output, now we need to make a circuit. So here we will go with the rectifier. Just place the component, okay, in this fashion, and make the connections as shown in a video. Now I'm just making the video quite faster because it will be lengthy otherwise. Okay, so just do the connection as shown in a video and you can take a screenshot of the same. Now here the capacitors are connected. We need to give the ground. The ground will be there with at the left side where yellow colored two-sided arrows are shown. Okay, so we place the LED now and the resistor of course. So the resistor will be of 1K right now we are using. Now we can use a DC voltmeter to check the voltage. Okay, here I'm changing the value of resistor, that's it, and changing the name of LED also, it will be red LED, that's it, and placing the ammeter and checking the values whichever I want. I'll keep that only, otherwise change all the values. Okay, now at the input side we need to give AC. So where is the AC? AC is there with the generators and ground is there with the terminals, right? So I have connected here. Now in a normal circuit or in a practically we cannot connect another terminal of transformer to the ground, but here in a Proteus we have to do that because we are giving AC by the generators only. Okay, so 230 will be the amplitude and 50 will be the frequency. Okay, so we just go with this. So our circuit is completed. Now we will have the complete circuit over here. If we simulate this, we will get the result. Okay, you can, yes, that's it, the LED is glow. Okay, so here you can see the LED is glowing. Okay, so simulation will give you representation. Okay, so we will just now place AC and DC voltmeters to check the voltages at the output. Here I am checking the voltage across the resistor and bit ground, right? So here we are expecting a 5 volt. So let's save and run it. So you are getting 5.02. Is it possible practically? No, it is not, because if you're using 7805 then there should be some drop and that will should reflect at the output, but it is not. So here you can see the 2 point something voltage there at the LEDs across the LED. Okay, so I have changed the value of resistor to 260 and just simulating it. Okay, so the voltage and intensity of LED is changed. While using the LED, you have to check the properties of LED by just clicking on it. You can see the type is analog, so you have to select that on a DC, and breakdown voltage you can change or else you can keep that as it is, but the DC will help you to get a stable DC way of representation. Let's add some AC voltmeter at the input side and the output side of the transformer. Okay, so here I don't think so you will get the value which we practically expecting. So let's simulate, save and simulate the circuit. You will get 162 at the input of transformer and at the secondary it is 156. So we actually not change the primary and secondary windings property, so we are not sure about it. Now if we change the value of C1 capacitor 2.2 microfarad and we simulate it, then you can see how much AC components are present in the output of rectifier. So if we change that value to 22 microfarad, you can see how the capacitor removes the AC component and you get the DC stable value. So this is how the capacitor is used and we require that. Okay, hope you understand how the transformer power supply is working. Okay, so please do like the video if you understand, and do share, subscribe to my channel and press bell icon for latest videos.